the other one is now the variable types. We have three variable types. One of them is local, the other one is instance, and the other one is the static variable. So what are those? Basically, the local variables are the variables that we define within a function, within an if statement or a for loop, or within just a code block. These are called the local variables. So for these ones, we do not define whether it is final, whether it is public, private, protected. We don't use it because their visibility, accessibility is very limited. We just access it in that code block. Like if I define a function, a variable within a for loop, I can only access it within that for loop. Or if in a if statement, I can only access it within an if statement. And they do not have any default value, which means that if I don't assign a value, I will get an error. So for those things, now we'll just do an for that. So again, I will just open my Eclipse. Yes. And then I'll go to, let's say, our A, just to show that. Now, I want to define one more function for this to explain what we meant. So let's define a dummy function for it. So if I define any variable here, int x is equal to 5, let's say, I cannot access it here, which means that I cannot print x here. I'll just get an error because it's in a different function. So I can use it only here. Or if I define within an if statement, okay, and then if I define a variable here also, then if I try to attempt it here, again I'm not able to, because I just defined it here. It means that it can be only accessible within that if statement, not in outside that. But there's one thing, like what is the accessibility of x here? Can I use it within that if statement?
Yes.
Yes, I can use it here. So because when I declared it within this f function, it means that I can use it in any place of that f function. But here, I just look at the code block that is defined. Like I just defined it within this if statement, so I can use it only within that if statement. So this part is important. I cannot use it even outside. In Java also, there's this interesting part. In Python, you don't have it like this at least. If I just use a code, open a curly bracket and close it, okay? I didn't put any if statements. I didn't put anything. Then this actually becomes even a code block, which means that if I define it something inside that, I can, of course, use it within that block. Oops, what happened? I can, of course, use it in that block, but I cannot access it outside that block. Like I'm getting an error here. Because I said that, okay, this z, parameter z, is defined for this code block, and that code block, it's not if statement, it's not for loop, while loop, it's not a function. I just said, okay, this is a code block. Okay, then its visibility became only within these two curly brackets, and you cannot use it outside that. This is called local variables. And when I'm doing it, if I don't assign any value here, like I just said int x, and then I try to print it, okay? Then I'm getting, then let's try to call this. So what I'll do is let me make it something I can run, okay? Oh, I have a bigger error here. Yeah, all right. As you can see now, I'm getting an error here. Int x and then print x, because it doesn't have any default value. Java is basically saying, okay, what should I print? Like, I don't know what the x is. So this is happening with the local variables. Now, I'm going to, if I'm going back to the instance variable.
Why would it not print the memory reference of x instead of nothing?
It's not a memory address location. Like if we could do it in C. I could get the memory
Oh,
of
okay.
it, but in Java, no, we don't actually deal with the memory address location. Especially it is it's a local variable, so there is no default value in that. So basically, Java is forcing you to assign a value if you want to use it. But this is not the case in the instance variables. What is an instance variable? Instance variable are the variables that we define within a class, basically the attributes of a class. So we define it within the class, but outside the methods. And then what we do, why is that important? Well, when I said, okay, create me a rectangle class, okay, in which I put this height and width as an attribute, then when I say that rectangle R is equal to new rectangle, basically what we are doing is we need to allocate some space for that object. And then how much space should be allocated for a rectangle object? Well, Java knows it from this instance variables. Like, okay, for that one, for that object, I need some space in my memory so that it will be allocated for that object. And for that object, I will use this term a lot. We will allocate memory for an object in the heap. What is heap? Well, in real life, it is this one, the one that you see. But in computer science, when we say heap, it means actually the dynamic part of the memory. When I create an object, I'll say, okay, we allocated memory in the heap. But what do I mean is actually the memory, the dynamic part of it, okay? And when we use it, the new, it is created, and then it is destroyed when that object is destroyed also in the memory. And we can use access modifiers we use access modifiers for instance variables like public, private, protected, or default. And I think we talk about this. And instance variables have default values, so you don't need to initialize it. If it is an integer, it will be 0. If it is Boolean, it will be false. If it is an object, like string, it will be null. So you will not get an compile error if you attempt to use them without even you initialize that. And you can access instance variables through the objects, like you can create an instance of that variable and of that class or of that object, and then you can access those variables, or within that class definition, like rectangle.java, I can access all these variables. So their visibility is across all functions within that class. Do you have any question about instance variables?
If I create an object inside a loop,
Yes.
An instance variable, or is it a local?
Oh, that's a perfect question. When I create an object within a for loop or with an if statement, that object, the definition, like let me also open my thing here.
If we have a for loop to create many objects, for instance.
Yes, I'll go to here, and then yes, I will within a for loop. I will basically create many rectangles, but it doesn't have to be. Now this rectangle object is, this R object is not accessible. It's a local variable. So if I'm trying to access anything, I'm not able to. I'm getting an error because it is a local variable. But what is accessible is R's. Of course, we set them private. That's why we are not able to do it. But this width and height are the instance variables. So even though I don't initialize them, I can use it. But these are the instance variables. But this R object itself here is actually a local variable. All right. An object in the heap, and then it is destroyed. When the object is destroyed, since you are not a C developer yet, if you want to learn it, then actually creating an object in the heap is pretty problematic, because once you create it, you have to also clean it when you are not using it anymore. But in Java, we are not dealing with memory almost at all. Mostly we don't care about it, because the garbage collector handles it, removes it, the objects that are not used anymore. So when you start learning programming, either Python or Java, mostly, yeah, we don't know how to manage the memory. But if you start learning C or C++, then you realize that, okay, memory management is something that you really have to worry about it. Oh, I think, yeah. I was trying to talk about this. So if you know Java, you don't need memory management mostly. All right. Do you have any question? Let me continue. I think that will be good if I can finish this part, please. The other one is the static variables. So what is this? Static variables, for that one we use this static keyword, and then it is defined again within the classes but outside the methods, like instance variables. And then a static variable will have only one copy during the execution. What it means is, and then all the instances share that one copy. And I'll come to my code, but before I want to start finish it here. And when we start the program, they are already created, and then when the program ends, they are removed from the memory. And now let me do just an example for that. I think the most challenging part is it is shared by all instances. What does it mean is, now let's go to our rectangle object, okay? Let's say that in our rectangle object, we have these two variables, width and height. They are not static. Oh, sorry. This always happens. I move here. Okay. Now you see, yeah. In the rectangle object, we have non-static variables, instance variables, which is width and height. And then let's say that I want to create an static one. Let's say static x, whatever it is. So for that one, I said it is static, okay? So how can I use it? Well, when I create a rectangle, let's say R1, okay, and let's say R2, each of their width and height variables are not shared. They are separate values. What it means is, when I said, okay, for now I would like to make them public, okay, to make my point much more easy to explain. Okay, I'll just make them public. So I can set the width of R1 to 5, and then I can set the width of R2 to 10, and then when I print that, they will be different variables. Like can easily say that, okay, this is R1.width, and then I would like to print also R2.width. So basically they are different variables. They are not shared across instances. R1 has its own width value, which is 5. R2 has its own value, which is 10. So they are different. But for the x value, what is that? Like I can, if I say that, okay, R1.x, which is my static variable, okay, I'll set it to 100, okay? Then in my calculation, I will also print x, but through R2. So I said R1 is x, R1.x is 100, but I'm trying to print R2.x. So I'm using different instances, but when I print it, I get 100. So I changed the value of x through R1, but it affected the value of R2.x. So because they are using the same variable, it's a common variable that is shared across all instances of that class. Okay, so normally, and because of that actually, since this is only one variable, normally, I mean, usually we don't also use it through instances. It's also possible to use these static variables without creating any instance. So I can even make it to 150, let's say, but note that what I use is I use the class name. Rectangle.x is equal to 150. And then I can, again, just print it to r1.x. Let's print r1.x again. Now let's see the answer. It printed 150. So again, I changed it like this, rectangle.x, and then it affected this r1.x. Even though I had set it to 100 at the top, when I change it, it is also affected. So basically, the static variables, Java creates a single variable for that class type, for that object type, and then all the instances uses the same variable, so that whenever we do a change, all of them are affected by this. So this is what a static function, a static variable is. Do you have any questions so far?
Is it the same as a constant, a final?
Constants, finals does not allow me to change the value. In the static ones, I can change it to 5, 100, 150, but in the constant, when I say that it is final, I am not allowed to change it. So there is this difference. But we usually, in many cases, we also set constants as static just for an easy access. I don't need to create an instance to access it. I can just access it through like rectangle.x, so I don't need to create an instance. So this is also a common thing that we can do. Okay, it's 2:50, so I think I should stop here. Thank you for your attendance. This is the class for today.